Welcome. In this video, we're going to express this function as the sum of a power series and find the radius and interval of convergence. Okay, so first, before we go on, let's recall, and those of you who have watched my videos already or are going in order in my class, etc., you might want to skip ahead since I'm just going to show you the key power series again. Okay, here is the key power series. So if you have not been following along, we have the sum from 0 to infinity of x to the n is equal to 1 plus x squared plus x cubed, and so on. And as long as the absolute value of this x is less than 1, this series sums to 1 over 1 minus x. And if you notice, I've highlighted them all in green, and I'll get back to that. For now, let's rewrite this to look more like this, which is going to take some work here. Let's use polynomial long division to start. So x plus 2 divided into x minus 1. So x goes into x one time, and we multiply to get x plus 2. Let's go ahead and subtract. X minus x is 0, and negative 1 minus 2 is negative 3. Now from here, this is my remainder of 3, so let's go ahead and rewrite this. So using polynomial long division, I can rewrite this as 1 minus 3 over x plus 2. Okay, let's continue to rewrite this. This is 1 minus 3 times 1 over 2 minus negative x. And then I can rewrite this one more time. This is 1 minus 3 over 2 times 1 over 1 minus negative x. Excuse me, not negative x. This should be negative x over 2. There we are. Take a moment and verify that you agree that this is the same as this, and then verify that this is the same as this. So take a moment and verify that. Okay, so now we can apply what we see here. That is, I'm going to highlight this in green. This is my blob, and this is going to replace each of these blobs. So really, I'm going to rewrite this as 1 minus 3 over 2 times 1 plus negative x over 2 plus negative x over 2 squared plus negative x over 2 cubed. Ooh, and I'm running out of space here, so I'm going to have to scooch this one more time. Those of you on paper, writing on paper, do your best to squeeze your work in as you can. There we are. Plus negative x over 2 to the 4th power, and I'll stop here. Okay, so this is 1 minus 3 over 2 times 1 minus x over 2 plus x squared over 4 minus x cubed over 8 plus x to the 4th over 16. Okay, I'm going to keep rewriting this and rearrange again slightly for the sake of space. There we are. So this is 1 minus 3 halves. And this is just me, this is me distributing the negative 3 halves everywhere. 1 minus 3 halves plus 3x over 4 minus 3x squared over 8 plus 3x cubed over 16. So that was me multiplying these two, There we are. Now I'm going to do these two terms multiplied to get negative 3x to the 4th over 32. And I'll stop there. Now these are like terms, so let's go ahead and combine these like terms to get negative 1/2 plus 3x over 4 minus 3x squared over 8 plus 3x cubed over 16 minus 3x to the 4th over 32. Okay, so now that we have this written out, let's look for a pattern. So as you can see, this first term doesn't have a 3 multiplied to it, but the rest do. So the easiest thing to do is start with negative 1/2 plus a series. And I'm leaving this blank here right now, so I can show you intuitively the best number to start n at is just 1, because then every exponent is just x to the nth power. So I definitely want a 3, and then I want a negative 1 that's going to alternate. So when n equals 1, we're here and we want it to be positive, so I can't have an nth power here. I need to have an n plus 1. And then, of course, we've already mentioned we have x to the n power. And then in our denominator, there you are. Now let's go ahead and find the radius and the interval of convergence. And then just as a quick reminder before we do so, we have figured out that x minus 1 divided by x plus 2 can be expressed as this power series right here, as negative 1/2 plus this power series. Now let's go ahead and look at the radius and the interval of convergence, and we're going to do so with the ratio test. Recall for the ratio test, we want to look at the limit as n approaches infinity of a sub n plus 1 over a sub n. And we want to verify that that is less than 1. So basically, this power series will converge when this absolute value is less than 1. Okay, so let's go ahead and look at this. My a sub n term is x to the n over 2n plus 1. Oh, excuse me, I forgot the 3. And my n plus 1 term is 3x to the n plus 1 over 2 to the n plus 2 power, because I have n plus 1 plus 1. So that'll give me n plus 2. So let's look at the limit as n approaches infinity of the absolute value of 3 to the x to the n plus 1 divided by 2n plus 2. And then, of course, we want the quotient of this with the a sub n term, so that's divided by 3x to the n over 2n plus 1. So this is the limit as n approaches infinity of the absolute value of 3 to the x to the nth plus 1 power over 2n plus 2 times 2 to the n plus 1 power over 3x to the n. All right, now this is done. Let's do all that simplification. So 3 divided by 3 will give us 1. And then we have the limit as n approaches infinity of x times. If you're having trouble seeing this, pause your video and remember your rules of exponents, what will happen. You can always bring this up as a negative exponent. Same here, I move this down as a negative exponent, so 2 to the negative n plus 1, and then simplified. Now, this limit here will be less than 1 if and only if the absolute value of x over 2 is less than 1. This tells me that my interval of convergence, actually, this is true if and only if, and this will give me my interval of convergence. The absolute value of x is less than 2, and this can be rewritten as negative 2 less than x is less than 2. So that's my interval of convergence. And my radius of convergence, r is equal to 2. Now, I want to point out there is more than one way to skin a cat. You could have done this several different ways. You could have split this into 2 fractions and recombined your power series. You could have factored out this x plus 1. I personally wanted to show you the long division method. So however you get there, doesn't matter so long as you get there. Hopefully you found this all helpful.